Good day, my BC250 friends. Today I have some interesting project to show. As you can see, this is very beautiful 3D printed case which came straight from Australia, and it was designed and printed by NextGen 3D, and I can tell you that it's extremely high quality case, and the most important, it's made to accommodate the liquid cooling system, which means that our BC250 will run fast and very quiet. So let's see what exactly we need to make sure that it will work as we expect, or even better. Alright, so here you can see everything what we need in addition to the case in order to make liquid cooled BC250 Steam Machine Pro. So, of course, first of all, this is our BC250 board, which is having the main heatsink removed. Okay, so then what you will need is a bunch of those small heatsinks, which we are going to apply on the all elements, VRM and so on, in addition to liquid cooler. Then next is liquid cooler. So this is the IO liquid cooling system made by the Teucer. It's the most budget friendly 240mm liquid cooling solution. Next, what we're gonna need is the power supply. So this is the LOP 12 volt, and this model is 600 watt, but the case can accommodate any LOP from 400, 500 and 600 series. I opted for 600. Alright, so another thing we need is a small cooler which will cool down the power supply. Another thing I almost forgot, this is the special very reinforced bracket to fit the cooling base to the BC250. It's also made and designed by NextGen 3D. Later, of course, I will share all the links to his models and to his shop. Quality is amazing. It's made of high temperature resistant plastic, and later you will see how it fits. So, talking about power supply, another thing we need is high quality cable to connect to BC250. We need also small connector to connect power supply to 220. This is the plug, the receptacle which we're gonna use. Additionally, what we have here, this is a small module by Corsair which is made to control multiple fans and also RGB. It also has two thermal probes which are connected separately, and we will be able to control all of the coolers, pump and so on by this little module. Additionally, we need this small USB hub by Anker, Why? Because first of all it's very good and cheap, and the case made by NextGen 3D, it's actually made to fit the fan controller, USB hub, this small 80mm fan, and so on. And we will need additionally one Type-C to Type-A cable to connect this unit. Okay, so basically this is all we need for a moment, and now I'm gonna open the case and show you how is it made inside. Alright, here you see the case in disassembled form. It is very well designed. It consists of only 8 pieces. So you have the top mesh panel, the bottom mesh panel with little fits. You have side panel with a cutout for the USB. You have another side panel. They are both mesh, so ventilation is perfect. You have one bracket which holds inside of the case the power supply, and you can actually slide it out if you need to disconnect something. You have one front panel, and it's made in such a way that you can customize the logo. You can have different image printed on it, and this small strip is actually transparent because inside of the case we have an LED strip which is gonna be connected to the controller which controls the fans, and also RGB, so we can program to have different colors and light actions. So remaining two parts are basically the two halves of the case which slide in one into another, and they are also being held by the top panels and the screws. It is very robust. The quality of the printing is very high. You have here the necessary cutouts for USB, for display port, LAN, power supply, and this is the front part which has replaceable customized design front panel. Okay, so inside of the case we have designed supports which will lock the small fan, 80mm fan. Here there is a designed space for the controller of fans and RGB. On that area there is a slot for USB, so here will go our hub, and USBs will be easily accessible on the side of the case. And you can see on that side we have the power supply and the original panel from BC250, where we're gonna have reset, power, and outlets for the other USBs. Okay, what is also great, what I noticed, that all screws which are used in the case, they are absolutely identical, so you will not mess up anything. Very easy to open, very easy to close. Okay, so let's go to the board and connect the water cooler and insert it in our case. Alright guys, time for cooling system. So I replaced the original fans from the Teosir liquid cooler with Arctic P12 Pro. I installed additional mesh protectors just in case inside of the case any wire or cabling will not have a contact with the blades of the fans. Then the bracket, apparently this bracket fitted perfectly Teosir 240mm liquid cooling solution. It's just exactly managed to accommodate it. So inside here it's made like a sandwich, so you need to open the top part and the bottom part. Then I used the Intel brackets to put in between, and after that I had to close the sandwich so the the cooling block is properly secured inside, and it will go to the APU on the top and will be secured in 4 corners. You will see, I'm gonna attach it and come back to you. Okay, so now the cooling system is installed. It wasn't easy, honestly, to be able to properly adjust to make sure it's even. I hope I did succeed. I turn around to see how the chip is actually touching stuff. Down below you have this nice bracket which is making the even pressure. Yeah, I don't know how much I need to torque these screws because they're actually resisting a lot. Springs are actually quite stiff, but I don't know where is the limit. I don't want to break anything. It seems to be a quite good pressure. Okay, let's see. Alright guys, so I'm slowly moving towards the assembly, all the components to the case. So installed here Commander Duo, installed here fan. In my initial video I made mistake. This fan is actually made not to cool down the power supply, but to cool down, board is standing like that, is to cool down a VRM. So here you have the VRM. This is very hot part, so the fan is located over here and blowing and cooling down the GPU and CPU power circuits, which are getting very hot, the MOSFETs and the other components. Okay, so here on the board itself I attached the next gen 3D bracket. It perfectly fit on the one, not even 1 millimeter on each side, but it's perfectly fit my TUSR budget 240 millimeter liquid cooler. It's installed, it's flying over the APU. On the back side over here you have the supporting bracket to prevent the board from bending too much. The smart thing about this is that there are springs over here, so once you tight, actually you basically cannot over tight, because at one moment springs are starting to compress and the pressure is evenly spreaded. But it's tricky, you need to position very well to feel that the cooling block is standing on a APU, and cross slowly to tight all 4 screws. Otherwise you can tight it under the let's say not in straight position, and then you will be having some troubles. So it was a little bit tricky moment, but it's actually doable and working very well after. So additionally, this is my own addition, I would like to also cool this part of the board, so I put small 10 millimeter slim fan over here, 80 millimeters, which I'm gonna connect also to Commander Duo, and it's gonna cool down this part of the board. It's not absolutely necessary. SSD is not getting hot because it's very slow speed port, but I noticed that other components are slightly warm, not hot, but I decided to put one extra fan. Actually what I used here, you have 2 original screws which are holding the aluminum back plate, so I just used additional I replaced the short screws which normally is supposed to be secured by these nuts which are provided by when you buy this bracket for cooler, but I use it to secure the plate, and excess of the thread I used to secure on diagonal the cooler, because it's actually matching perfectly the dimension of this cooler, standard 80 millimeter cooler. So that was my solution. I hope it's not a bad idea. From the board you have to remove this this metal IO bracket, because actually inside of the case you have printed and cut opening, so the board will slide and match perfectly. All this IO will match to the case. Okay. On the 240 millimeter TUSR liquid cooler, what I did, I replaced both fans with Arctic P12 Pro, because they are designed for static pressure. They are much better, and at minimum RPMs like 900 or something like this, system is incredibly cold. I don't need to hear any noise, so it's fantastic stuff. So I just added these 2 fans, and I put additional grills to protect, because inside some cable or wire can make a contact with the fan, and I don't like it. Here on the board, the pump block we connect to the CPU fan header, and the AIO liquid cooler, you have to interconnect between each other the fans, and this header will go to the Commander Duo over here, together with the fan for VRM and so on. Here, so what we have here, we have here LOP600. I attach it to the printed bracket coming with the case. I included separately, I had to order this socket with the switch, and connecting it here to LOP 220 connector. Over here we have standard screw type contacts. So I attached many cables, I crimped the ring connectors, put them on and screw together. It's a little bit messy, but I have plenty powers to connect. So what I have here the PCIe connector, but because I'm gonna overclock CPU and the GPU, I used also these two ports in order to provide additional to supplement PCIe with these two connectors, microfit, Molex microfit connectors. You have on one row 3 plus, on another 3 grounds. I will show later on how it's connected. So I have all this is for supplying power. Additionally, which was not mentioned by NextGen, by the designer of the case, because he has perfect bill of material in his website, but one thing was missing is the SATA power supply connectors. I a little bit made it this way. So this SATA power connector is actually energizing, it's plugging here, it's energizing Commander Duo. You only need 12 volt. So this side wire is the 12 volts and these two are grounds. Here used to be in the center used to be 5 volts, but I cut it because you don't need it for Commander Duo, but you need to have it in order to run the fans and LED. Over here we have LED strip, which is also connected to Commander. So we have like steam machine, like nice lights, RGB light strip. What else about the power supply? So here I made some add-on. This is not normally not supposed to be part of my project, but I came to another project in the GitHub and I like it. So what is this? This one is ESP32 board with 2 relays. Originally the designer of this project, this is the standard let's say 2 relay ESP32 board with which programmable with Arduino IDE program. So originally the author of this project, he used this board to energize the standard ATX power supply by this relay, programming this relay, which will give command to the ATX power supply to start supplying the power to BC250, and this relay he used to energize the BC250. It's connected to the power button on BC250. So what was the idea? This module has Wi-Fi and Bluetooth, and you can program it in such a way that once you push on PlayStation 5 controller, the PS5 button, it starts to communicate, trying to pair by the Bluetooth with PlayStation. This chip detects the signal and energizes the relay and switching on BC and power supply. Okay, so in my case I'm not using the ATX power supply, I'm using the LOP 612. So I rewire in such a way that I'm still going to use the PlayStation 5 controller to switch on the board, but this relay will energize the Commander Duo. And yeah, I still have some wires to connect. These are the wires which will go to power button, because I also added, which is not foreseen, but I added one power button over here, so I can switch on the console by power button, by joystick, or by the button here on the BC250 board. Okay, and there are some wires which I will show the diagram later, which has to come to the BC. I soldered them here on TPMS header and on the back side here to the power button. I will share all the wiring if you would like to do it, but if you buy the board, what you're gonna need is actually something like that. This is the interface, USB UART interface, which you use. It used to be connected here, but I for a moment removing it. So the idea is that with this USB interface you can put the program inside of the memory of this unit. You can program it, flash it in such a way that it will work as you wish, and I will also leave a link for this project. So I'm gonna try to fit everything inside. Hopefully there will be enough space, because this relay is not supposed to be inside by the design by NextGen 3D printing, but I checked there are few corners, few spots here where I am gonna put it. So wish me luck, and I will show you once everything is being in the case. Alright, thank you. Another small but very nice detail is that actually here the case designer NextGen, he made the special slots which will actually allow the BC250 to slide and to these notches are made to slide inside the BC250, and the back plate, actually the aluminum part, is going under this part here, and in the other part of the case you have same slot fabricated here and there. So once the BC250 goes inside, this part over here and over there on the other side of the case, on the other half, they are actually sliding inside of these slots over here. You can see it here. So like that, it's nicely secured inside the board itself. So please, before trying to put it inside, you have to check that these slots are clean, that the BC can slide nicely inside. Maybe you have to work them out a little bit, and then it will work very well. It will secure nicely the board inside of both half of the cases. Alright guys, so I'm almost completed assembly. You can see here is the back plate of the BC250. I improvised and installed small heat sinks approximately in location of every video memory chip. However, as per the NextGen, it's not necessary to do, because here you have kind of suction of the air, and it's supposed to be cold and not overheating. Here there is a temperature sensor which is connected to Commander Duo, so I could monitor this temperature. Okay, so inside you have big opening. Here is the fan which is blowing to VRM. I also added, if you can see here, one more temperature probe, both of them connected to Commander Duo. So one fan is actually the fan daisy chain, two fans of the water cooler, second one is the VRM. Here on this side you can see the small slim fan which I improvised. That one has no PWM control, it's just being switched on as soon as the board is energized and cooling down this part of the components. LOP 612. Over there you can see the body of the water cooler. Here it is. So I'm gonna install all the outside meshes to make it look nice again, and we're gonna run and make few tests to see how it's actually performing. Alright, so stay with me.
Sounding off 3 AM and no escape.
So guys, what I can say at the end of my video. I'm very happy of how this project went. I'm very happy with results and with the process. It was fun, it was very interesting, and the liquid cooling on your PC 250 will not guarantee that you will get some extreme overclocks, because that's what is depending on the board, on the silicon lottery. Some boards can achieve very high frequencies, some not. But what liquid cooling and the case by NextGen 3D can guarantee you is that you can reach the maximum of your board, depending how lucky you are, but for sure you will be able to achieve maximum frequency for your board, and the system will run quietly without any fan noise, nearly silent, which is very good. And of course it is good looking. The case by NextGen looks like an OEM product from a good brand. The quality of print and the way it is designed and amount of small details is incredible. One more thing I would like to say about the remote control project. This is the GitHub resource. Here is the name of the project, and there are all details. I was consulting that web page. There are some explanations. They are quite limited, honestly, but I managed to figure out how to install necessary program, how to wire the relay, and how to flush the firmware. You have enough information, and of course, if you have questions, I will help you. You can leave the questions in the comments, and I will try to assist you as much as I can. I'm gonna share my sketch of how I wired the relay board ESP32. You can see here, this is the momentary LED power button which I added. These two contacts are going to the LED light of the button, and these two contacts they are connected this way. They are actually closing the circuit of the power button. You can see here the small description of TPMS connector on BC250. You can find the detailed connector in the internet. You need to connect two contacts 17 and 9. And here you can see this is how the pins of the power button are on the BC250 board. So you will be able to find easily the positive connector of the power button and connect it to the relay. So the relay, both relay, you need to look for normally open contacts. What I noticed that my relay was not exactly the same as in this project. You can see that here are different connectors, different points of connection. And first, when I followed that diagram, my relay wasn't working correctly. And then I realized that normally open contacts on my board are located like that. So in my case, you can see here that I take 12 volt from the power supply, I feed it to here, to the VCC, not like in the other project where the for ATX power supply you connect it to 5 volt terminal, because on the LOP power supply you don't have 5 volts, but this connector can take from 7 to 30 volts, so you can connect 12 volt this way, and ground is going to the ground wire. And what's what happens when you activate the relay is that this relay is making one momentary close and energizing the BC250, and this relay is actually closing and stay in close position during the operation of the BC250. Like that, the power commander can receive 12 volts and you take a ground from the same PSU. And exactly this way I have connected my relay and it works perfectly. I can start BC250 from the external power button, from the power button on the board, and by the PS5 controller. Another project which I've used during my case build is OpenLink Hub. This is the software which is made for Linux in order to be able to use dual Corsair Commander Duo. Corsair Commander Duo works with this software. It's opened like a web page, and you can monitor temperature of CPU, GPU, and in my case I put two thermal probes. One is going to VRAM and another one is to graphical memory. Here you can set up the speeds of the fans and so on and so on. Also worth mentioning that before you use your Corsair Commander Duo for the first time, you need to connect it to Windows computer and flash the firmware. It's accessible on Corsair website. It will be very easy to find for you. The same software will allow you to flash to the Commander Duo default values for your fans and for your RGB, meaning that before Commander Duo is communicating to the OpenLink Hub program, once the Linux is booted, it will just run with default values which you can set up once. Only you need to do it only one time in Windows, and after that, as soon as the communication between OpenLink Hub and Commander Duo is detected, it will go to your preset, which you can do via this software. This project of Commander Duo and remote power on of BC250 deserve a separate video, so I cannot continue with more details about these two topics. So I will need to slowly finish my video, but of course before I can say goodbye, I want to say big thank you to the Next Gen 3D Printing. Great guy. He made several fantastic cases for air-cooled version of BC250, for liquid-cooled, and so on and so on. Please, I strongly suggest you visit his shop. If you interested in the cases by Next Gen 3D, you can purchase. He delivers almost all around the world. And what is incredible, that he allow all his models to be downloaded and used for free. So if you don't like to use his printing service, which I strongly suggest because quality of print is absolutely amazing, you can just download his models following the links in the description or the one you can see on the website, and you can print the cases or any other fun stuff he has from his models, which are available for free. If you would like to do the same project as I did, here on his webpage you have one very important list, which is a bill of materials. Here there is a full details of what components you need to purchase in order to be able to print yourself the case and assemble everything in order to make your own Steam Machine Pro liquid cooled. So once again, great thanks to NextGen3D, incredible job, incredible quality print cases, and he always very quickly responding. If you have any questions, you can find him in BC250 Discord community, in Reddit, or on his websites. For now, I want to thank you. Thank you for staying till the end of this video. I hope it was interesting, and I hope to see you next time. Thank you. Bye bye.